resistors in series. Resistors in series. Here three resistors are connected in series, R1, R2, R3. Okay, total potential difference given by the battery is V. Current I flows through the conductor. Okay, then potential difference V1 across R1, V2 across R2 and V3 across R3. We know that effective resistance in series is what? R1 plus R2 plus R3 plus etc. We have to add the algebraic sum of individual resistances. Okay. And here we can say total potential difference is divided. Total PD is divided. Total potential difference is divided. That means V equal to V1 plus V2 plus V3 plus etc. Okay, in series connection. And listen, current is same for all. Current I is same for all. For all resistances in series, same current flows through it. Okay. And listen here. Current I is same for all. Total potential energy is divided. R effective equal to R1 plus R2 plus R3. Okay. I is same for all. Okay. Now listen. If n identical resistors are connected in series, n identical resistors are connected in series. N identical resistors are connected in series, then we can say Rs equal to R plus how many Rs? N R. So R effective equal to Rs if N identical resistors are connected in series. R effective equal to NR. Rs equal to NR. Then total potential difference is equally divided. Total PD is equally divided. PD is equally divided. That means all resistors are identical. So 12 volt battery is connected in to a series connection of 3 identical LED bulbs, for example. So 12 volt battery 444 will be the potential difference of all the LED bulbs, like that. N identical resistors are connected in series. So N resistors are R resistance is N times in series. That is why NR is the effective resistance if the resistances are N identical resistances are connected in series. Next, resistors in parallel. Okay. Battery V, positive terminal, negative terminal. Resistance R1, R2, R3. Okay, current I will flow. That current splits into 3 pieces. I1, I2, I3. Current I splits into 3 pieces and they combine at this junction as I. Okay, so we know that PD is same for all. Potential difference is Same for all in parallel connection, and current I is divided. Current I is divided. I equal to, we can say, I1 plus I2 plus I3 plus etc. How many parallel connections are there? All currents should be added. All currents should be added. Current is divided. Okay. So what is the effective resistance? Here effective resistance 1 by R effective equal to, we have to write 1 by R1 plus 1 by R2 plus 1 by R3 plus etc. We have to add the reciprocals of individual resistance to get the reciprocal of effective resistance. To get reciprocal of effective resistance. 1 by R effective equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus etc. Okay. Two resistors are connected in parallel. Then we have to take 1 by R effective equal to 1 by R1 plus 1 by R2. By solving them, we will get R effective equal to, if two resistors are in parallel, if two resistors are in parallel, then R effective we will get what? R1 R2 by R1 plus R2. R1 R2 divided by R1 plus R2. Okay, now if three resistors are in parallel, then what will be R effective equation? R effective equal to R1 R2 R3 divided by R1 R2 plus R2 R3 plus R1 R3. If three resistors are connected in parallel, R1 R2 R3 divided by R1 R2 plus R2 R3 plus R1 R3. Three resistors are connected in parallel. Okay. If n identical resistors are connected in parallel, n identical resistors in parallel, n identical resistors in parallel, then we have to write 1 by R effective in parallel, Rp equal to 1 by R plus 1 by R plus 1 by R plus, how many 1 by R's are there? N into 1 by R, that will be 1 by Rp. Then what will be Rp? Rp equal to R by N. Rp equal to R by N. Rp equal to R by N when n identical resistance are connected in parallel. So if R resistance R is connected n times in parallel, if resistance R is connected n times in parallel, then we have to divide R with n, R by n. That is the effective resistance in parallel. So here we can say current is equally divided. Current is equally divided. Okay. Like in series connection, potential difference is equally divided for identical resistance. Here current is equally divided. Okay. When n identical resistors are connected in parallel. When identical resistors are connected in parallel. And here we have some questions to solve. Okay. Question is the same question. Find the effective resistance between A and B. Find the effective resistance between A and B. That is the common question to all networks that I am discussing in the class. Okay. Common question for all. Find the effective resistance between A and B. Find the effective resistance between A and B. This is the question commonly for all the networks that I am using. Okay, going to discuss. Find the effective resistance between A and B. Okay, first network. First network. A, B, all are identical resistors. All are identical resistors. What will be the effective resistance? What will be the effective resistance? Can you find? What will be the effective resistance? This network, you can see, you just assume current is entering at A. A is connected to positive terminal and B is connected to negative terminal. We have to assume like that. A is connected to positive terminal of battery, that is current is entering at A, and B is connected to negative terminal of battery, that is B is connected to, current is moving away from, okay. Then a part of current I enters to the top network and I2 network goes to the bottom network. So you can see I1 current will pass through this resistance to this resistance. Same current passes through the resistance or along the top path. Okay, so we can redraw this network as like this. Here it is B, here it is A, this is R, this is R, this is R. And here you know R series, then we will get what? Here it is 2R adding and at the lower it is R. Okay, first question, that is why I am explaining. Okay, no need of explanation, we can just go to the final result from the initial step. Okay, now look, 2R parallel with R, right? 2R parallel with R. 2R parallel with R. So our equation R effective equal to R1 R2 divided by R1 plus R2. So we will get R effective equal to what? 2R into R divided by 3R. R plus 2R, okay. Then we will get 2R by 3 is the effective resistance. 2R by 3 is the effective resistance because 1R will be cancelled. 2R by 3. Okay, next question. Same question, this is the second question. Find the effective resistance between A and B. Find the effective resistance between A and B. Can you calculate? Just assume A is connected to positive terminal of battery and B is connected to negative terminal of battery, right? Listen. So a portion of current will enter at this position, right? So that current will pass through these two resistors. That current will pass through these two resistors. So the two are in series. The two are in series. So we can write these two are this as 2R. This is actually 2R. Actually 2R. So now look, a portion of current will pass through this arm and another portion of current will pass through this arm. And both the currents joins at this junction, right? Both the current will join at that junction. Once more, a portion of current will reach here and another portion of current will reach here. So we can say 2R are parallel. 2R are parallel. 2Rs are parallel. So we can say 2R parallel with 2R. We will get this as R. 2R parallel with 2R. We will get effective resistance as R. Effective resistance are R. Because 2R 2 times comes in parallel. So 2R by 2, that is R. Now look. So here the total resistance is R. Then look. Current I reaching at this position. Current I reaching at this position. From these two arms, current I reaching at this position passes through this resistance, right? Up to this. So we can say this R is in series with this R. These two R's are in series. Then we will get what? 2R as effective resistance. 2R as effective resistance. This together gives effective resistance 2R. Effective resistance 2R. Effective resistance 2R. Okay, now look, here is a current 2R. Here is a current 2R. Current reaching these two 2R up to this is joining from the current coming from here. So we can say the overall 2R is in parallel with this 2R. Overall 2R is in parallel with this 2R. Overall 2R is in parallel with that 2R. So we can say they are in parallel. So 2R parallel we will get R. 2R parallel we will get R. So this overall gives again R. This overall gives again R. Again R. Yes. Now we can again reduce. This is called a reduction method, right? Reduction method. Now this R is in series with this R. Listen. Here we have a resistance R, right? Here we have a resistance R. The current flowing through this R reaches at this junction and passes through this R. So that this R and this R are in series. So we will get effectively, total resistance is what? R. Total resistance is what? R. Sorry, 2R. R series, we will get 2R. So we can say up to this we are getting resistance as R. Up to this we are getting resistance as R. Okay. But this overall gives, R in parallel. So we are getting resistance as 2R. Resistance as 2R. Again series connection. So resistance as 2R. Now you can say this 2R is in parallel with this R. This 2R is in parallel with this 2R. So we will get R. So overall the resistance here is what? R. R in parallel. R in parallel. Listen. This 2R. Once more. This 2R is in parallel with this 2R. Then we will get R. So how to get R here? This overall gets the effective resistance as R. Now you can say this R is in series with this R. So we will get R. Okay, this R is in series because same current will pass through this. Current reaching at this junction will pass through this. So R series we will get 2R R in series we will get 2R. And here we will get the final network as here it is 2R and here at the R A, B, and here we can say 2R parallel with R. Then we will get R effective equal to what? 2R into R divided by 2R plus R, 3R. Then we will get the result 2R by 3. Okay.